Hello, 7th hour. This is Mr. Green. I am going to be gone today, so once again I've left you a video. Now this time I've tried the negative filter. Hopefully some things are a little bit easier to read, easier to see, so you'll have to be sure to let me know. So today we're going to talk about estimating square roots and cube roots. Okay. So if we take a look here at our first example, it says you know that the square root of 8 is not a whole number because 8 is not a perfect square. Okay. Remember our list of perfect squares here. 1 is a perfect square, 4 is a perfect square, 9 is a perfect square, 25, 16 is a perfect square. Okay, so 8 is not a perfect square. The number line below shows that the square root of 8 is between 2 and 3 since 8 is closer to 9 than 4. So the best whole number estimate of the square root of 8 is 3. Okay, so when we're talking about this, we are comparing our radicands, or the number underneath the radical sign. So since 8 is closer to the closest perfect square, which would be 9, we know that it has to be about 3. Okay, since the square root of 9 is 3, the square root of 8 has to be around 3. Okay. So if we take a look at a few examples here, I want to estimate the square root of 83 to the nearest whole integer. Okay, the nearest whole integer. All right. So the perfect squares that are around it are going to be the square root of 81, okay, and the square root of 100. All right. Now the square root of 83 is right in between those two. Okay. Now since I know the square root of 81 is 9 and the square root of 100 is 10, it's going to be, the square root of 83 will be somewhere in between 9 and 10. Now 83 is pretty close to 81. It's closer to 81 than it is 100. So if I'm rounding or estimating to the nearest integer, I'm going to say the square root of 83 is approximately 9. Okay? And that's what these squiggly equal sign means. Okay? That means approximately 2. So the square root of 83 is approximately 9. Now if we move down to number 2 is a cube root. Okay, it is a cube root. So I have to look at my list of perfect cubes. Okay, I know 216 is a perfect cube. That would be 6 cubed, and 7 cubed is 343. Okay, so the cube root of 343 is 7. The cube root of 216 is 6. Well, I have the cube root of 320. So I know it's going to be in between those two, right? 320 is less than 343, but it's bigger than 216. So our cube root of 320 has to be in between 6 and 7. Since 320 is closer to 343, I can estimate the cube root of 320 to be approximately 7. Is approximately 7. Okay. At this point in time, you can pause the video and let the students work on these problems under the Got It section. Alright, hopefully you've restarted the video. If we take a look at the square root of 35, we know this should be approximately 6. Since the square root of 36 is 6, 35 is close. B should be approximately 13 because the square root of 169 is 13. So the square root of 170 is close. C, 44.8 is very close to 49, and the square root of 49 is 7. So this is approximately 7. D, E, and F. Now we're looking at cube roots. Okay, the cube root of 62. Well, the closest perfect cube is 64, which is 4. So this is approximately 4. The cube root of 25, okay, that is a trick question. Make sure you realize it is a cube. Some of you will see this and write down 5, but that would be the square root. We are looking for the cube root. Okay, so the cube root of 25 is close to 27, and the cube root of 27 is 3. And lastly, 129.6. 129.6 is close to 125, which is 5. There are your answers for the Got It section. Moving on to example number 3 here, we have a word problem. Okay? we have a word problem. It says Wyatt wants to fence a square portion of the yard to make a play area for his new puppy. The area covered is 2 square meters. How much fencing should Wyatt buy? Okay, so if we know the area of a square is equal to the side length squared, we know the area is 2 meters. Okay, so I have 2 meters equals a side length squared. If we remember from yesterday how to undo a square for a variable, that would be a square root. What I do to one side of an equation, I must do to another. Square root. Okay? So on this side it cancels out, I can make a mullet. Okay, and I have s is equal to the square root of 2. Now, the square root of 2 does not come out even. Okay? So I must estimate. Okay? Based on our principles we learned before, the square root of 1 is 1. Here's the square root of 2, and the square root of 4 is 2. So it's somewhere in between 1 and 2. Right? Now, the closest estimate would be to 1. Right? But the problem is if we estimate this to 1, we're not going to have enough fencing because that's less than the actual amount. So what we want to do is estimate this to 2, okay, or approximate it to 2 so that we have enough fencing. So if one side length is approximately 2 meters, okay, we have 4 sides of a square, we know we should buy 8 meters of fence. Questions? That's funny because I'm not here to answer your questions. That's just a bad habit of mine. Okay. Moving on, why don't we do this one together, because this one is a bit different than the last one we just did. So it says Kelly needs to put trim around a circular tablecloth with a diameter of 36 inches. Use the equation C equals pi d to find 3 sets of approximations for the amount of trim she will need. Truncate, which means to cut off, not to round. Okay, so we're not going to look to the right and bump it up or down. We're just going to stop it. Okay, the value of pi to the ones, tenths, and hundredths place. Then determine how much trim she should buy. Okay, so we know my diameter is 36, so I know that's going to go in for D. I'm trying to find C, and I know the value of pi to be 3.1415926535897. So I have C is equal to, first I'm going to truncate to the ones place. Well, 3.1415, on and on and on. If I cut it off after the ones, that's just 3. Okay, so I have 3 times my diameter of 36, okay, and I know this is equal to 108. Okay, so now I need to try and approximate it to the tenths position. So C is equal to 3.1 times 36, which is 111.6. Lastly, I'll do it to the hundredths. C equals 3.14 times 36, okay, which is 113.04. Okay, so here are our approximations for the amount she would need. So, my question is, which one would be more accurate? Okay, the answer is 113.04 because it uses the most of pi. Pi is an irrational number that goes on and on and on forever and ever with no repeating pattern. Okay, so the more accurate you are, the further you go into the decimal. Okay, now the problem here is when it says determine how much trim she should buy, many people will just say 113.04, but the problem is pi continues on past 3.14. Okay, it's not zeros after that, there's numbers. Okay, so that means it's actually larger than just 3.14. So a couple things you can do is just round 113 up, or you can take this 113 or 3.14 and change it into 3.15 because that would be bigger than anything that's left on the pi. Multiply it by 36 and you get 113.4. So you know you need at least 113.4 inches of trim. Now most people, if they were actually going to go do this in real life like Kelly, would just probably buy 115 or 120 and have some left over. But where this becomes important mathematically, or where these mathematics become important, is if you are dealing with millions and millions of dollars at some gigantic corporation. Okay, you want to waste the least amount of material as possible. Okay, if you make 1,000,000 tablecloths in a day, I don't want to waste 1/10 of an inch on each one. That adds up to be quite a bit of material that I'm just losing, and that ends up being profits that I'm losing. Okay, so it becomes important when you talk in the manufacturing and business world. All right, and the last example we're going to look at here has to do with the golden rectangle. I'll talk more about the golden rectangle on Monday when we get back. It's a very, very interesting ratio, but really what it is the ratio of the long side of a triangle or a rectangle to the short side, and it's repeated a lot in nature. Here we see it with a nautilus shell. Basically what we need to do is estimate this value. So I have 1 plus the square root of 5 all over 2. I don't need to estimate 1 and I don't need to estimate 2. What I need to estimate is the square root of 5 because that's an irrational number. Okay, so I estimate the square root of 5. Here's the square root of 4. Square root of 5. The next perfect square is the square root of 9. Square root of 4 is 2. Square root of 9 is 3. Okay, 5 is obviously closer to 4 than it is to 9, so I know it's going to be closer to 2. So I can estimate this as 2, or if I wanted to be a little more accurate, I could do 2.1. So 1 plus 2.1 over 2 is 3.1 over 2, which is 1.55. Okay, now this value has been estimated, okay, and I've answered my problem. Okay, so estimate your irrational numbers, okay, or approximate your rational numbers, and then you just solve the problem and evaluate. Okay, all right, here is the assignment. Okay, normally that's on a black screen, so it looks very interesting right now. Okay, red, yellow, green. Let's see if I can turn the filter off. Maybe that. There is our assignment. Okay, please work on it for the rest of the hour and have it done for Monday.